Communication is important. It allows me to convey my thoughts. So when you hear my words, they make sense. Or at least, I hope they make sense. So the fact that I'm speaking in English, and you can understand English, well, it allows us to communicate. What happens when you have different OT devices in the field built by different vendors, and you want to link them together? Okay, this might be an apples to oranges comparison, but bear with me. Within layer 2 of the TCP/IP stack, there's Address Resolution Protocol, or ARP. This protocol makes it possible for 2 or more devices that don't otherwise have a convenient way to communicate to join a network. ARP does this by resolving their machine address control, or MAC address, and associating it with an IP address so your non-internet connected printer can talk across the network to your computer. There are a lot of assumptions here. For one thing, ARP does not provide methods of authentication. Usually, you're just connecting devices on an internal network. And bad actors, they shouldn't be inside your internal network. Nonetheless, there are examples of ARP poisoning, where someone creates a MAC address with the intent of intercepting messages. So think again about the office printer. That 20-page legal document that you just sent to the printer might now pass through a bad actor's machine before it reaches the printer. This is a classic example of a man-in-the-middle attack. Again, how might this relate to an OT device out in the field? Because of the differences in devices, in RTOS, in languages, there's a protocol that allows most OT devices to communicate with each other. Thus, you can set the temperature across multiple devices from various vendors, and you can receive data from those devices on your HMI. This is the story of OPC-UA, a machine-to-machine protocol, and how a vulnerability in its implementation could have left machines worldwide open to attack. I'm Robert Moshe. This is Error Code.
I'll start. My name is Sharon Brizinov. I'm the Director of Security Research at Claroty.
My name is Noam Moshe. I'm a vulnerability researcher in Claroty Team82.
Claroty is a cybersecurity defense company trying to protect industrial network, healthcare networks, so anything around OT, IoT, and medical devices.
So let's start with a definition of what is OT.
Yeah, so OT, operational technology, is a certain type of network, computer network, that mainly consists of devices that have something to do with the physical world. So, for example, if you think about machines that produce something, manufacturing line, you have the physical actuators and you have the sensors, for example, temperature sensor, but you need some kind of an orchestrator that will control all the inputs and outputs, and this is the PLC, Programmable Logic Controller, some kind of a computer that you can remotely program its logic to control the operation and physical process. So OT network is the entire network where all these devices sit together and work together in order to create something physical.
Aside from the manufacturing example, OT could also have more mundane examples, such as elevators.
Sure. So elevator is a part of modular networks in a specific network called BMS, Building Management System. But yeah, 100%, it is also considered part of an OT network.
What Sharon and Noam presented at Black Hat is a vulnerability in Open Platform Communications Universal Architecture, or OPC-UA protocol. And it's used across most OT devices.
Yeah, sure. So in the past a couple of years, we've been researching in the Claroty research team, Team82. We've been researching OPC-UA. OPC-UA is a standardized protocol very common in OT networks. Its main goal is kind of to synchronize different devices and different systems on some values. So, for example, if you want to have one device producing some kind of a value that is correlated to something in the physical world. For example, it keeps track on the current temperature, and you want to synchronize other devices or other systems with this value. So you would use OPC-UA to sync all the devices and systems with this value. So it lets you transfer and communicate on certain types of data, specifically what we call tags or points in our physical dimension.
One of my problems with IoT-related protocols, like MQTT, is that they're really old, and they've been shoehorned into modern-day use for which they were not originally designed. So I'm wondering if this OPC-UA protocol has been around for a while, or is it a relatively new protocol?
So OPC-UA is the new version of an older protocol called OPC, or in its more complete name, OPC-DA. So OPC was the first protocol in the OPC category that was supposed to unify this kind of information transfer between devices and systems in the OT network, but it lacked some features and it was pretty limited due to some constraints. So OPC-UA was developed to cover this and to progress and make it better. So OPC-UA has been around for, I think, more than 10 years, which is not so much in terms of industrial activity, but it's definitely one of the most popular and most common protocols in OT networks these days.
Given the number of protocols that are out there, what made Sharon and Noam start researching this one? What were they looking for at the time?
As I mentioned, OPC-UA is a standardized protocol, so it's very common, and many vendors agreed on supporting it because they wanted a protocol that will be used by all the vendors, regardless the specific equipment and specific protocols, proprietary protocols being used by the vendors. So this fact made OPC-UA a unified universal protocol that everyone can communicate because all the vendors are agreed to support it. It made OPC-UA a very popular protocol in the industrial world, and so obviously it has huge impact if some flaws are found within specific hardware or software equipment in industrial vendors or companies.
So that's good. They were looking for a universal protocol that might have vulnerabilities that could affect a large number of vendors. Better that the good guys find that than the bad.
So obviously, since Claroty has a lot involvement in security of these networks, we want to make sure that current modern implementations are secure. So we started to look on different servers, appliances, products that support OPC-UA, and then we started to find some bugs. In addition to that, since it's a very important protocol, ZDI, it's a sub company of Trend Micro. They also wanted to push the industry forward, so through their Pwn-to-Own competitions.
So Pwn-to-Own, the competition, is a bit different from your usual bug bounty competitions.
Hello everyone, and welcome to Pwn-to-Own Miami 2023. I am Dustin Childs, Head of Threat Awareness here at the Zero Day Initiative, and I just wanted to take some time and show you around. First of all, you see the room, you're here because we got the great sign out front, including TX1 Networks, which is our sponsor for this year's event. So happy to have them as a co-sponsor and very glad to see their involvement. Let's come in the room and check things out.
Pwn-to-Own competitions are hacking competitions. They offered prize money to any researcher or security researchers that will find and report bugs or actually vulnerabilities in this protocol. So it gave our team a lot of, it incentivized us to accelerate the research on this.
So Pwn to Own, teams are given a list of targets and they have a few weeks to prepare. Then they have a certain amount of time on stage to present their vulnerability. If they fail within the given time, they fail. And if they succeed, they get points and potentially money. And these Pwn to Owns are pretty focused and spread out around the world. For example, there's Pwn to Own Vancouver, there's Pwn to Own Toronto, and there's the ISC one at Pwn to Own Miami.
Yeah, so particularly Pwn to Own Miami is the OT brand of Pwn to Own. They have a lot of sub-brands. Like in Toronto, you have the IoT competition, and in Miami, you have the OT competition. And in the last 3 years, we've participated 3 times, and we actually won the Master of Pwn Award this year. Specifically, it was mostly on OPC-UA and different OPC-UA implementation, be it servers, clients, and even gateways. So yeah, we've participated a lot in Pwn to Own Miami, and we currently hold the title of Master of Pwn in Pwn to Own Miami.
So we saw some great research over the 3 days. I know I have my personal favorites, but I wanted to ask Brian, what was your personal favorite exploit that you saw this week?
Well, my personal favorite was one from Claroty. It was actually one of their very last entries. It was against Softing Secure Integration Server. And they'd been teasing us all week that this exploit was going to take forever to disclose. And so we actually scheduled it so that it would be over our lunch and we could sit there with them for an hour and a half as they went through all the details of this specific case. And so when we got in there, they revealed to us that they had actually changed 6 different bugs together, all logic vulnerabilities, to actually gain code execution on the Softing server. And so it really truly was a piece of art, and when those bugs are disclosed and that blog is out, it's going to definitely be worth reading to understand the best way to kind of look at that attack surface outside of the box.
As I said, the rules that Pwn to Own follows are different from your typical hackathon. So the Master of Pwn category, it's quite a feat. You have to get so many points in so many categories in order to become that.
Yeah, so basically at the start of the competition, ZDI, Zero Day Initiative, issue a list of targets. These targets are different devices, different servers, clients, gateways, different kinds of software or hardware kits, and they are the targets for the competition. And on each target, a wanted outcome is decided. For example, a remote code execution, an unauthenticated remote code execution is the outcome. And a specific set of points is issued to whoever manages to find a vulnerability that exploits it in the specific way. And during the competition, everyone registers for their desired target list that they've uncovered vulnerabilities for. And all the issues are presented on stage. And whenever the competition ends, the amount of points is basically issued, and whoever has the most points gets the Master of Pwn Award. And during February this year, we actually won the competition, meaning we had the most points. We exploited
around 10 targets.
Yeah, I think either 9 or 11 targets. Gaining remote code execution in all of them, a lot of them. Some of them were a denial of service attack. So either a denial of service, which is actually pretty critical when we're talking about physical programs. Like if you manage to somehow DDoS or DOS a device, it could have physical effects, which could be even more severe than just gaining remote code execution, because we are talking about disturbing the process instead of, so which could be even critical. So yeah, we either exploited 9 or 11 targets and gained the Master of Pwn Award.
And so what we're going to talk about today is a flaw in the protocol OPC-UA. But rather, is it in the protocol itself, or is it in the implementation of that protocol?
So it's a very good question, because for OPC-UA, there is since it's a standardized protocol that has been developed through a very long period of time, the specification for this protocol are very firm. So the specification are very thorough and complete. So it's very difficult to find flaws in the specification. Usually the case is when developers are trying to implement, to write the computer code that correlates to the specification, and then some implementation flaws arise.
Over how much time are we talking about?
So we were given 2 months or 2 to 3 months in advance with the target list. And basically you need to do your research and find vulnerabilities on all the different targets. And then you do it during 3 days in Miami during the S4 event, where you basically people schedule and on stage you should exploit each target, and it's a binary output, meaning you either succeed, you have like 30 minutes time span and 3 tries. You should have your exploit ready, and you just start the exploit and hopefully succeed.
And what are some of the industries that might be affected by the research?
First of all, you need to understand that almost every industry uses OPC-UA because it basically standardized the communication method. Before OPC-UA, if, for example, you have a PLC of Siemens, only HMIs and stuff like that support their proprietary protocol, which they do not share, could communicate with it. So instead of buying all of this proprietary equipment, which do not work with other equipment from different manufacturers and different vendors, OPC-UA was created in order for everyone to communicate using OPC-UA. It basically acts as a gateway between different protocols. And that way I can connect my, let's say, lift controller to my HMI or to my screen or etc. Or of course my PLCs to my HMIs and my actuators, etc.
HMI is human-machine interface. It's a dashboard that reports out what the OT devices are doing.
So it basically acts like a common gateway. And in OPC, we have 3 different devices. It could be an OPC server, which basically every different kind of device connects to it, and it acts like the main server holding data acquisition, handling it. We have a gateway that communicates one protocol to another one. And lastly, we have clients. Think about it like if you know an HMI screen, which needs to present like a level of water tank, for example. And during our research, we actually attacked and found vulnerabilities in all 3 different entities, both in servers, gateways, and clients. And I can present to you, for example, the client exploitation technique, which we found 2 different popular client software. We found a similar vulnerability. Basically, the client connects to an OPC-UA server and tries to read tags from it in order to present something visually. So we thought to ourselves, since a lot of clients are built using a web browser, for example, they present my HMI using a web browser that presents my HMI screen, what would happen if we could somehow inject malicious JavaScript code during the tag reading? So our attack surface is pretty simple. Our attack approach, we basically lure a client into connecting to our OPC-UA server. And whenever they read a tag or, for example, the metadata about our server, we inject malicious XSS payload, and we have control on the browser. We can execute JavaScript code on the browser. And then we use this privilege chained together with a few other vulnerabilities to actually exploit the OPC-UA client and execute code on it.
In this attack, it's not just manipulating the HMI. By chaining together other vulnerabilities, you can actually manipulate the OT object itself.
Exactly, because we exploited this both on inductive automation ignition, which is a very, very popular server that basically does data acquisition and presents to you a UI, a GUI of an HMI of your screen. So first of all, we lure the client into connecting to our malicious OPC-UA server. We send a malicious tag, OPC, just like Sharon said. In OPC, the main data business logic is reading and writing tags. For example, what is the water level in your tank? And we weaponized one tag that whenever it is read, an XSS payload will be executed. And then we actually exploited the Ignition server itself. We did a project upload procedure and executed code in some logic during the process upload procedure. And we did it from the user's browser, meaning once we executed JavaScript code using the XSS vulnerability we found in the OPC-UA client, we use this browser in order to do a project upload on the server and chained another vulnerability in order to achieve remote code execution on the inductive automation server, the chain of vulnerabilities.
So I'm kind of wondering, was the target that they had in mind, say, a water utility? Or what type of industry actually would we be looking at here?
So because OPC-UA is so general, because it basically needs to support every different protocol, and that way you can connect your PLC, your water tank, like you just said, or it could be like physical manufacturing, food and beverages, oil and gas. There are a lot of industries, like almost all modern industries use OPC-UA in order to act as a centralized protocol in their manufacturing or in their building, etc. It is mostly an OT protocol, meaning it's less of a BMS, like you said with the lift, but more manufacturing, food and beverages, gas and oil, stuff like that.
Remember, OPC-UA is applicable across a lot of different industries.
Exactly. And so let me talk about the presentation we'll be performing in Black Hat. So like Sharon said, we've conducted our OPC research over the last 3 to 4 years, where we've looked at different products that support OPC, different SDKs, different software development kits that are very, very popular in different fields in the industry. And during these last 4 years, we actually try to look at OPC-UA at the protocol level, meaning we try to look for vulnerabilities that could affect not only one vendor or one specific code implementation, but more of like an idea of a vulnerability that a lot of different vendors and a lot of different products could misimplement it, where something is not clear enough, something is not specific enough, and look for like basically a logic vulnerability, and try to look for how it could actually be implemented in real life. So we basically amassed lots and lots of different vulnerabilities and tons of different products, which I'm sure we'll be happy to share with you, and try to look for protocol level vulnerabilities. During that time, of course, we developed different kind of vulnerabilities IDs. For example, if we're talking about an ID where basically in OPC-UA you communicate using channels. You open a channel and then you can communicate with the server. And our idea was, what if we would send a message which would take the server a long time to process? We could be talking about a few seconds all the way to a few minutes. And then during this message, while they are still processing it, for example, we would close the channel. Then whenever the server would try to act and use our session object, it would actually be freed already if we're talking about CPP code, and the null pointer reference vulnerability would occur. This vulnerability, we found a few servers that implement the idea of long request and freeing up the session, and we found different servers that were affected by this idea of a vulnerability. Another one is, for example, chunk flooding, where in OPC, you can send one message that is separated into different chunks. And the way the client tells the server, hey, this is the last message, they have a flag. What would happen if we would just keep sending different chunks and never send the last chunk flag? The server would allocate more and more memory, etc. Or, for example, the idea of sending a very complicated message where each of the parameters in the message is an object of objects, and so on and so forth. And we would perform basically stack exhaustion vulnerability on the server, where they would need to allocate and call another function of parse my object. And once again, it is a list of objects that every one of them is also a list of objects, and so on and so forth. So these kind of vulnerabilities are like a protocol ID vulnerabilities, where we try to look at many different products that could be affected by them.
So given that it's a protocol, who do you talk to about mitigating this? Do you talk to all the different vendors who are implementing it? Or is there an actual administrator of the protocol that you contact?
So first of all, the vendors should fix so whenever we find a vulnerability, we're reporting this to the vendor, and we're working with the vendors to fix the vulnerability. Once the vulnerability is fixed, the vendors are issuing patches and fixed versions, which asset owners have the responsibility to upgrade and patch their software within the factory or within the OT network. So it's a shared responsibility of researchers to find and report vulnerabilities, vendors to fix vulnerabilities and issue fixed releases, and asset owners to upgrade their software in the network.
So Sharon and Noam practice responsible disclosure. So when they present this at Black Hat, they've contacted the vendors, and the vendors have pushed out a patch.
Yeah, I think almost all of the vendors issued a patch.
And how do you get the word out? I mean, obviously, speaking at Black Hat is one way to do that. It seems like this is a vulnerability that is fairly common, and therefore not all the asset owners might be in the audience at Black Hat USA.
Yeah, that's why we've been working with the vendors for a very long time, and we made sure patches and fixed versions are available. And we also communicated this to the community, so asset owners will be aware of this and hopefully will upgrade their software.
There must be some certs that you can reach out to.
ICS CERT, this is the organization led by CISA, the cybersecurity infrastructure in the United States, and they're definitely the leaders in ICS CERT organization.
And so these organizations begin by spreading the word of the vulnerability, that you need to update immediately, et cetera, and they would be the ones issuing that.
True. They will be part of the chain. They will also, so usually we're also using their assistance to coordinate with the vendors. So CISA, or specifically ICS CERT, are part of this chain by working both with researchers like ourselves and also the vendors, and they're pushing both sides towards an agreement and towards very specific timeframes for fixing vulnerabilities, and also notifying the general public by issuing security advisories.
So given that we've focused a lot on software today, in the hardware space, in the OT space, I'm wondering what the maturity is like. When vendors are approached with these sorts of vulnerabilities, do they have the capability to deal with that? Or are they still somewhat immature and they don't really know how to respond to security research?
It very depends how mature the vendor is. So since we've been researching the most common software and hardware and equipment, so these companies are quite mature in both their customer base, so they have huge customers, and therefore they have the responsibility to make sure their products are secure, but they're also very mature in how they receive vulnerability reports, handle them internally, and providing fixes in a kind of a short time, relatively short time. So we're talking about a couple of months. But yes, most of the vendors we've been working with are very mature, and they actually were very happy to receive these reports from us instead of from someone whose intention is to do some harm.
Again, it seems like for a number of years, OT vendors kind of coasted along in security by obscurity. There weren't that many researchers poking at it, so that was okay. There weren't that many vulnerabilities.
Yeah, true. In recent years, due to multiple factors, actually, ICS vendors became much more aware of security and much more acceptance of security researchers conducting penetration testing on their products and producing vulnerability reports to them. So I would say that the current situation is that ICS vendors are very acknowledgeable and acceptance towards receiving vulnerability information and working with the vendors to fix those.
And some of that security through obscurity was through the diversity of PLCs and RTOSs and so forth that were out in the OT field. Now you've got this common protocol that's linking everything together. Therefore, there are more opportunities for the bad actors to get in.
You know, why the security domain has developed so much in ICS areas is due to convergence. The convergence between IT and OT. So in the past, OT networks were completely disconnected and even air-gapped from the IT network. And so researchers or even IT security analysts or administrators did not have any type of access to these devices. So they had no chance to research or to interact with these devices. So once we started kind of the convergence process between IT and OT, so modern OT devices are fully Ethernet based. So it's much easier. The barrier to interact with an OT device is much lower, and so researchers are starting to discover more and more vulnerabilities. And this is exactly the change we've seen in the past few years. So more vulnerabilities started to be discovered. So it's not like there were no vulnerabilities in the past. It's just they were hidden behind bureaucracy and behind accessibility to OT equipment.
So thinking about it, it seems like we're actually lowering the bar here, and that it isn't just going to be a nation state that's going to be able to attack. It's going to get down to a criminal organization as well.
True, 100%, yeah. And in recent couple of months, we've seen ransomware gangs targeting OT equipment. Yeah, you're definitely right.
So we do see ransomware going after different interests within OT, such as oil and gas, or critical infrastructure like water utilities and electrical.
I think so. So if we're talking about, for example, ransomware groups, they will try to address or attack anything that will potentially be of financial gain for them. So if we're talking about shutting down an hospital just to gain some financial reward, yeah, they'll definitely go for it.
At Black Hat USA 2023, Sharon and Noam didn't just talk about the vulnerability they found, they also announced a framework to help OT vendors check their products.
Yeah, we can definitely talk about OPC exploitation framework. So maybe I'll start with a short background story for this. So as Noam said, in the past few years, we've been researching OPC-UA products. This includes the SDK, so the very source code that you can implement in your software to gain OPC-UA capabilities, but also OPC-UA fully ready software and applications, servers, clients, etc. So we've been doing a lot of research. We found a lot of different vulnerabilities. And in the past, so we've been doing this research for a very long time. And from almost the very beginning of our research, we implemented a kind of a OPC-UA exploitation framework, very similar to Metasploit, where we're adding all of our exploit payloads of OPC into the framework. So with time, we started to collect more and more exploit payloads implemented in our framework. So now we have a very powerful framework, and we've been using this to research all of the products. So for example, if we found a vulnerability in one product, we implemented the payload to trigger this vulnerability, and now we were able to check all the other products and maybe to find more bugs of the same category using our framework. So we So now we have this great framework we've been using to research all of these OPC-UA products, and we've been thinking to ourselves, maybe we can share this with the vendors so they can check the same payloads on their products. Maybe we've missed a couple of products, or we were not thorough enough in our tests. So we actually created kind of a small coalition of many OPC-UA vendors, and we shared this framework with them so they could do some homework on their own products and use our framework to test the security of their products. So it was very beneficial. They used this framework for a few weeks. I'm not sure yet about the results, but I do think they found some more vulnerabilities that were not covered before. And we're also going to present this framework in Black Hat.
Yeah.
We'll be making this available as an open source, but it was very important for us to contact as many OPC-UA vendors as we can and share this with them a few weeks or even months before the actual release.
I'd really like to thank Sharon and Noam for talking about their Black Hat USA presentation. The OT space, it hasn't gotten enough love in terms of vulnerability research in recent years. And as more and more attacks are focused on our critical infrastructure, it's way overdue for serious security scrutiny. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. DM me at robertvamosi@infosec.exchange on Mastodon and tell me what you like and even what you don't. I have new shows coming up, including more on quantum. Subscribe today. I don't want you to miss out.